So now let's start talking about projectile motion. What is a projectile? A projectile is an object upon which the only force that acts is gravity. Examples of projectiles include an object dropped from rest, an object thrown vertically upwards, an object which is thrown upwards at an angle to the horizontal. So a projectile is any object which, once projected or dropped, continues in its motion by its own inertia and is influenced only by the downward force of gravity. So when we talk about projectiles, the most important thing to recognize in it is the force of gravity that is attracting it towards itself. So let's consider first the case of a gravityless path. If you have a cannon that fires a ball and there is no gravity present, say you're in space, the ball will continue in a straight line out from the cannon all the way out. And that will continue to do so in accordance with Newton's laws. However, on Earth, because of the force of gravity being present, the ball will not continue on its straight path but actually fall down towards the Earth. So the difference between gravityless path and gravity turn on is the fact that the object will move in different directions. But what I want you to note in this case is at each interval of time, let's say t equals 1 second, delta t equals 1 second between these two, note that the actual trajectory of the path is the same. So at both of these, if you were to draw the vertical components, they will actually match up. Interesting. So now let's look at another example. So now gravity is turned on. We know we cannot get rid of gravity as long as we're on planet Earth. And now our cannonball is placed on top of a cliff and it fires. Note what happens to the ball as it falls down. As it falls down, notice what happens to the vectors as in its path. So at t equals 0 seconds to all the way down to t equals 12 seconds. Vx, which is the horizontal component of the velocity, is something happening to it? No, it remains constant. But the component y, which is the vertical component, is getting bigger and bigger and bigger as it goes, which is also represented in the graphical form over here. On the other hand, now remember we also said projectile was also the object when it was thrown at an angle to the horizontal. So let's say in our next example we have the projection angle to be greater than 0. Let's say it's about 30 degrees. Note what happens. This is now the path that the projectile follows. At t equals, as the time changes, no matter if it's going up or down, your velocity component x is not changing. This means that whatever changes the acceleration due to gravity is doing, it's not doing in the x component. Okay? So, however, for the y component, look what happens. As it goes up, it becomes smaller and smaller until at the absolute top it goes to 0, and then it starts to increase, but in towards the negative side. That just means is that we've chosen our coordinate axis to be plus pointing upwards and minus pointing downwards. Okay, so just note very carefully these two scenarios. In both of these cases, Vx is not changing and Vy is increasing as we are going downwards. Okay? Here's another way to look at the same thing. As we go downwards, Vx component, it doesn't change at all. But your Vy component, depending on the acceleration due to gravity, is actually increasing as we go. And at the top, the Vx component, Vy component is actually 0. So now how do we find velocity from its components? We've been talking about this multiple times, but here's what it will look like in a nutshell. So first draw Vx and Vy. Then draw two more sides to complete a rectangle. Number 3, draw a velocity projectile that's diagonal of the triangle. And then you can determine the magnitude of velocity by using the expressions that we've been using before. V squared equals Vx squared plus Vy squared, and tangent of theta will give you the angle of the velocity. Okay. Now, how does the projectile change with respect to time? So let's say we have a projectile. It has an initial velocity of 5 meters per second. So where will it be after 1 second? So we can do a quick math and we can figure out at time t equals 0, Vx is 5, 0, 0, and 0. At t equals 1 second, your x component will not change, but your v component becomes 10 meters per second, and your net velocity changes to 11.2. At 2 seconds, Vx does not change, but Vy changes to 20, and hence therefore your velocity increases. At 3 seconds further on, your Vx will not change, velocity Vy will change, as well as your final velocity and your angle theta. Now, homework. Pause this movie right here and go solve for t equals 4 seconds. What are the formulas that you are going to need to calculate Vy? Another very important term to remember and recognize when we're talking about projectiles is called the range. The range is how far along the horizontal axis will your projectile move. So let's say we have a cannon here and it fires a ball into the air. An angle is 45 degrees at which it is actually firing. Initial velocity 100 meters per second will result in your range being about 920 meters. If your angle is the same and your initial velocity is reduced by half, your range is going to decrease. Note, not by half, but actually more than half. And now if you were to change your initial velocity to 1 meters per second, your range will only be 0.1 meters. So initial velocity becomes very, very useful. Range becomes very useful, and all of these things you'll be able to calculate as the semester goes on. So, in order to talk about projectile motions, here's a classic physics problem. Get the food to the monkey. Okay, you are a zookeeper in a game farm, and there is a monkey, and you need to feed him, and he refuses to come down from the tree. Your job is to get the food to the monkey. So, one case scenario will be if there is no gravity and the monkey lets go of his hand when he's hanging down, and when you fire the gun, the projectile goes on forward, there's no gravity, it follows a straight line according to Newton's laws, and you get the food to the monkey, everybody's happy. Now, on the other hand, what happens if the gravity is turned on? And then if the monkey lets go of his hands, he is definitely going to fall. What happens to the path of the cannonball? How will you aim in such a way to get the food to the monkey? Now gravity is turned on. You aim towards the monkey, and you aim it to where you think he is going to be when the banana reaches him. And he misses it, and he falls to the floor, and you don't get anything. So in order to get the food to the monkey, if the banana is shot really, really fast, then the monkey will be able to get it. And also on top of that, note, if you were to draw a straight line from here to the monkey, this is where the monkey was when you took the shot. Okay, so we got the banana to the monkey. Now, if the banana is shot very, very slow, the two paths the monkey falling and the path here, as long as it's aimed directly towards the monkey, it will still reach it. I know it's a little bit surprising if you figure this out, but that's actually very true. Why is that? Projectiles launched horizontally. Whether the object is dropped vertically or launched horizontally, the rate of fall is the same. It always have the same acceleration, which is 9.8, and it is due to the acceleration due to gravity. Okay? Projectile's horizontal speed is constant unless there is air drag. As long as we don't consider the air drag, we pretty much can assume that the horizontal speed is absolutely constant, and there is no acceleration in that direction. Okay. Another important phenomenon is the fact that all objects will fall towards the ground at the same speed. It doesn't matter if one is bigger or smaller than the other, the mass is independent. Same thing here, two objects will fall at the same rate as long as they are falling towards the earth, even if they are projected with an angle.